ladies and gentlemen, boys and girls. My name is Mr. Do, and science is my business. Welcome to Mr. Do Science World, and today we're going to look at mathematics. And the aspect of mathematics we're going to look at today is calculus, and that is differentiation from the first principle. So we want to look at how, when we are given any given question, we will be able to differentiate that given function from the first principle. Okay, so let's look at it and see what we mean by first principle. Differentiation from first, f prime of x is equals to the limit as h approaches 0, f of x plus h minus f of x all over h. This is the first principle. And there is a possibility where you will solve a problem with this principle. The limit will exist, and there is a possibility where the limit will not exist. If the limit exists, it simply implies that the function is infinite. Okay, so we're now going to apply this in solving a problem. Let me try to explain to you this formula so that when you're solving a problem, you know exactly how to apply the formula. According to this principle that we have here, we can see f of x. Each time you are given the question will be in a form of f of x. The question itself that you are given is a function of x is equal to a certain expression, and that becomes the part which is already in the formula. Now when you go into the first part of the formula itself, then we can see that there is f of x plus h. The f of x plus h simply implies that wherever we see x in the function itself, we're going to put x plus h into the function that we are given. That's exactly what we just need to do in solving problems with it. So let's try by solving first example and see how to apply this formula. Okay, so I give example number 1 and say find the derivative of f of x is equals to 3x plus 2. So we want to find the derivative of 3x plus 2. That is the derivative of what we're going to use. But now, if I'm given the question like this, we can solve by using the differentiation rule or solving by first principle. But because we are dealing with first principle, so I'm going to say by first principle. So by first principle. Alright. So we want to find the derivative of this function by first principle. Let's begin from here. Right. Solution. Each time you want to solve the problem, the first thing to do is to write the formula itself. So I have written the formula, which is the first principle. And after writing the formula, I am going to write the function that I am given, because the function is part of the formula. So the function is f of x is equals to 3x plus 2. Now, the second part of the formula, which is not here, is f of x plus h. And as I said earlier, this simply implies wherever there is x in the function, I am going to put x plus h. So this will become 3 into x plus h plus 2. And then I'm going to expand this and say it is 3x plus 3h plus 2. And now I am going to go back. Now I have gotten the first part of the formula, the second part of the formula. I can now go back into the formula and do the substitution and simplify. So I'm going to have it as f prime of x is now equals to the limit as h approaches 0. F of x plus h is this. So I'll write that as 3x plus 3h plus 2. There is a negative sign, so I put in the negative sign. The next thing I have is f of x, and f of x is given here. Remember, these are two terms, therefore I need to open brackets because this negative sign affects each of the terms. So I open brackets and write a 3x plus 2 all over h. Now I need to expand. So I am going to expand that and solve the problem. So to continue, I write the formula and then I want to continue from here to that part. So remember, I'm going to expand this. This will become 3x plus 3h plus 2 minus 3x minus 2 all over h. And now let's look at something here. There is common numbers there that we can cancel out. We can see that there is negative 3x and there is positive 3x. They will cancel out. There is positive 2 and there is negative 2. They will also cancel out. What we are left with is f prime of x is equals to the limit as h approaches 0, 3h over h. Now let's look at something. The h and h can cancel out, therefore I am left with f prime of x is now equals to 3, and that is the answer that we are looking for. This is what we're looking for. Now let's look at something here. Let's assume that after cancelling out there was still h there. The value of this is approaching 0. It is not exactly 0, but because we just want to find what the exact value is going to look like, we're going to substitute that word 0 in place of the h into that particular part, and then we will solve the problem. But in this case, we are lucky there is no h out there, therefore our final answer is f prime of x is equal to what? 3, which is the first example. Okay, let's look at example 2. Let's assume that we are given the function. I'm not going to write the whole sentence again. Let's say that we are given the function f of x is now equals to x squared plus 2x minus 2. This is the function that we are given, and we are told to find the derivative of this function using the first principle. If I want to use the first principle, as I said to you earlier, the first thing to do is to write the formula down. So the principle is f prime of x is equals to limit as h approaches 0, and that is the function f of x plus h minus f of x all over h. That is our formula. I am going to just simplify, do the substitution, and then we solve the problem. So let's look at it. I go straight away and say f prime of x is equals to the limit. I'm solving it straight away. As h approaches 0, what I have is this function. Remember, this function is different from what we have here. This function is rather this. So for me to find this, wherever I see x, I am going to put what? X plus h. So let's move on. There is x here, it becomes x plus h. There is square, so I need to square that. Plus, there is 2. There is x again, I put the x plus h. And now we have what? Minus 2. Now the next thing we have, there is a negative sign here or a minus sign here. Put that negative sign. There is a function f of x, and the function f of x is this whole thing here. But remember, the negative sign affects each of these. So I need to open the bracket and put there x plus 2x minus 2 all over what? H again. Okay, so we need to simplify this and solve the problem straightforward. I am not going to write the function here again. I just want to go straight away. So it will become limit as h approaches 0. I will expand this, and when you expand this, it's going to give us x squared. 2 times x times h is going to give us 2xh, and then plus h squared, and we're going to have plus multiply this and we get 2x plus 2h minus 2, and now this is given as negative x squared minus 2x plus 2 all over h. Right, now let's look for like terms or common ones that we can cancel out. We can see there is positive 2x here, there is negative 2x. So these and that cancel out. There is x squared, there is negative x squared, they will cancel out. There is negative 2 here, and there is positive 2 cancelled out. What are we left with? We are left with 2xh plus h squared plus 2h. That is what we are left with. Right, so let's go back, right up here. So this becomes f prime of x is equal to the limit as h approaches 0. Okay, and what I have is 2sh plus h squared plus 2h all over h. And when I have this, the first thing that you can see is that there is a common factor. The h is common to all the top numbers. So we're going to do that and then factor out the h. So let's try and factor out the h from there. If you factor out the h, then we're going to have it as h into 2x plus h plus 2, and now all over h. And once we have this, we can see from here the h and the h will cancel out. And what we are left with is the limit as h approaches 0, 2x plus h plus 2. And from here, we are now going to substitute the value of the what? Of the h there. If I put in h here, it means that what I'm going to be left with is what? 2x plus what? Plus 2. Remember, this is not the exact value. We are talking about h approaching 0. So it is not exactly at 0. So there is no need to substitute the 0 into the function. But once we are having this, then we know that finally our answer will become 2x plus 2, because we know if we are to put 0 in place of the h, what we're going to have is just simply what we have here. So now our answer is this, and that is the derivative of the function that we were given. Okay, let's look at example number 3. This time around we want to look at a fraction. So let's say we are given f of x is equals to 1 over x. And we are told to solve this by the first principle. What do? Straight away we still have to apply the same rule that we use in solving the other problems. So we're going to have this as f prime of x is equals to the limit as h approaches 0, f of x plus h minus f of x all over h. I'm going to do the substitution straightforward from here. Remember we said in this case wherever we see x in the function we put x plus h. So this becomes the limit as h approaches 0, and this is now 1 over x plus h minus, this is the minus sign, this function is now here 1 over x all over h. And once I have this, I'll become limit as h approaches 0. This is a fractional sign. It is a fraction and we need to solve it together by multiplying each of the fraction by the denominator. So this becomes, the denominator is x into x plus h multiplied by this one, which is 1 over x plus h minus the denominator multiplied by the LCD again. Okay, so we multiply by LCD multiplied by this, which is 1 over x, all divided by the denominator. Sorry, all divided by the LCD, which is this. And now remember there is what? H there. So divided by h. That is one problem about solving fractional problems like this. If you're not careful, you're going to have a problem. You forget about this side, and then that becomes a problem and you get it wrong. Okay, so we're going to express this. Once I have this, remember, this is going to cancel this out. This is going to cancel this out. I'm left with x multiplied by 1. And then I'm left with here x plus h multiplied by 1 multiplied by the negative sign. So straightforward, what I'm going to have is going to be like this. Let me use a different color and make that simple. F prime of x is now going to be the limit as h approaches 0. And now it is x times 1, which is x. Negative times that is negative x. Negative times this, negative h. And we are dividing all by the denominator. This denominator, we can just expand it now and get what? X squared plus what? X h. Okay. And now it is divided by this h here. And if you can see, each time you have a fraction divided by a fraction. Say we are having, sorry, if I have 3 over 2 divided by 5, what I'm going to have is that to be 3 over 2, and that is going to be divided by what? By 5. So I will just multiply it by what? By the reciprocal of this function. So we're going to do the same thing for this here. But meantime, this and this is cancelled out, so we are left with the limit as h approaches 0, and that is going to be what? We are left with just the negative h divided by this all over h. Now I'm going to write this h and the division sign like this divided by this h, so that I can multiply by the reciprocal and make life easy. So I will have this, and that becomes negative h all over x squared plus sh multiplied by 1 over h. And again, we can see that this will cancel this, and once that is done, I am left with this function. And what is that function? That function that I'm having here, let me write that on this side, and this is just simply going to give me what? It's just going to become the limit as h approaches 0. What do I have? Negative multiplied by 1, that will be what? Negative 1 all over x squared plus x h. And now remember again that what we said is that each time we have anything like this, we are not taking the limit of this function. And if you take the limit of the function, our final answer is going to be negative 1 all over what? Over x squared. Let me write it well. X squared. And that is what our answer is. Okay, let me write here, this is f prime of x, and that is giving us this as our final answer. And that is that about question number 3. Thank you very much for watching this video, and in our next meeting we'll be looking at differentiation rules and how to solve or how to find a derivative by using what a differentiation rules. But please don't forget to subscribe to my channel. So please subscribe.